I can start my presentation. So containers for software developers. Now let me just move away so that you can see a little bit better. So welcome to this presentation, Containers for Software Developers. Today I'm going to talk about containers. First of all, let me just introduce myself. My name is Joel Lord. I am a developer advocate for Red Hat OpenShift. I am based in Ottawa, not that it really matters in a world of online events. But if you ever want to contact me, the best way is always by Twitter. I love Twitter. My handle is Joel with 2 underscores Lord, so Joel __ Lord. It's probably the worst Twitter handle ever, but hey, whatever works, right? So let's talk about containers and why you should use them. There's a number of good reasons to use them. First of all, it's really about the fact that it's the same environment as your production. So you'll carry that same environment over from your development environment and from your testing environment and to your production environment. So you always have the exact same environment. It's very useful for onboarding. If you have a new team member that joins your team, think about all the things that he needs to do in order to be able to work on your project. First of all, if it's a Node.js project, you'll need to ensure that he has the same version. If he still has a version 12, but you're using modules, well, that won't work, so you'll need to upgrade to version 14. So there's always all those steps in order to get a new member to join. And we've only talked about Node.js in this case, but imagine thinking about databases and thinking about all the other tools that you could potentially need for your project. And it's great for open source contributions. It actually happened to me once where I was using a software and there was a tiny little change that I wanted to do. The project was in PHP. Although I am familiar with PHP, I wasn't familiar with the framework that they use. But I knew that I could fix it. It was a tiny little issue. But now the other problem that I had was that I didn't have neither MySQL, I didn't have a data set, I didn't even have an Apache server installed on my laptop. So installing all of that just to do that tiny change, normally I would have just ended up doing a GitHub issue and say, hey, can anyone fix that? But turns out that they actually had everything containerized. So I was able, with one single command, to spin up everything, have a local data set that I was able to work with, do that little change, and submit a pull request, which made my life a lot easier as a contributor. It's also very good for testing. Great for testing. If you have a manual testing team, you've probably at one point got into a fight with them. Well, I got this bug. Well, I can't reproduce it on my machine, so not my problem, and you end up not fixing that bug. And that happens because environments differ from one person to the other. Also, containers are ephemeral by nature. We'll see that in a few minutes. But what that means is that all the data that you put in will be destroyed once the container is done, which is great for unit testing as well. If you want to input a lot of different things, if you want to add log files, if you have all those different things that are added as part of your testing process will be destroyed at the end. So you always start with the exact same state each time you want to start your testing. So that's a great bonus. So let's talk about what is a container. So a container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. It is a lightweight standalone executable package of software that includes everything needed to run an application: code, runtime, system tools, system libraries, and settings. So think of a container as one big zip file that would contain not only your source code, but it would also contain all the necessary tools to run your application. It's also a disposable unit. Once it's completed, it destroys itself along with all other dependencies. And that's very important. It's very important because you have to think in a container mindset when you start playing with them. You have to remember that everything will be destroyed. So you have to build stateless applications. That's very important. And the other thing is that if you need to preserve that data, there are ways to actually do it, but you'll have to keep that in mind as well. So I talked about containers so far. I mentioned Docker once or twice. So where does Docker actually fit into this whole Docker container scene? Well, Docker is one of the multiple tools to run containers. So Docker was used as a base for the OCI, which is the Open Container Initiative, and now there's multiple tools that can be used to run your containers. Podman is a great alternative by Red Hat. That is only for Linux, unfortunately. So, but if you do have a Linux operating system or a Linux machine, then you can definitely use Podman as an alternative to Docker. It uses the exact same syntax, but it's much faster. So let's talk about containers in practice. One of the first use cases that I had for a container was when one of my friends came to me and he was like, "Hey Joel, can you help me with this PHP code? I have an issue, can't figure out what it is." And that person knew that I used to do a lot of PHP, although I haven't done a lot these last years. And as much as I like to help my friends, but I didn't have Apache or PHP installed on my machine. But then I remembered containers, and I heard that it might actually help me for this. So this is what I did. I opened up my terminal and I ran the command docker run, and we'll run this as in the background, and I'll map some ports here, and then I'll make sure that I remove this. I'll give this a name. We'll call it, well, let's not give it a name for now, and we can mount some files, samples php /var/ www/html, and we will use PHP, let's use 7.1-Apache. All right, so there it is. We're starting our server, and there you go. So I've just downloaded the image. I have my server up and running, so I can now do curl localhost 8080, and you can see that I have actually just pinged I've just been able to reach my server. Now, if I go into my VS Code, I can go ahead and change my sample code right here. Where is it? Sample PHP index.php. So that was for a previous conference. Let's just change this to Connect.Tech. Hello, Connect.Tech. And now I can do a curl localhost 8080 again. And there it is. We have hello, Connect.Tech. So there you go. I was able, within just a few seconds, to start an Apache server pre-configured with PHP and be able to serve local files from my file system through that server. How cool is that, right? So this is kind of what you can do with containers. Now I went really fast with that command, so let me explain all of the different options that I've used with Docker run here. So to start a container, you will use Docker run, and you will give it the name of an image. So in this case, I use PHP as my image, and I mentioned the version that I wanted to run. So I wanted to start 7.1. The reason why I wanted to start 7.1 is because I already had that version cached on my machine. 7.1 is outdated now, so you should probably use 7.4. But I use it just because I wanted to use a cache, so it's a little bit faster. And I wanted a specific variant of PHP, so I didn't just want the PHP executable, I also wanted PHP with Apache pre-configured. So that's the image that I chose. If you go on hub.docker.com, you will find, and if you search for something like PHP, you will find multiple images and all the different variants, and everything is documented so you can really figure out which image that you want to actually use. The other thing that I did was to map some ports. I've mapped port 8080 on my local machine into the port 80 of the container, or of the container that is running. So really what happens now is that Docker, any request incoming on my laptop on port 8080 will automatically be mapped into the container, into the port 80 of that container. So it takes care of routing everything, all that traffic there. The other thing that I did was to mount a volume. So I said, hey container, take some files on my local file system and put them inside that folder inside the container. So in this case, I took my project, my PHP project, and I told Docker to actually map that into /var/www/html, which is the folder that Apache uses to serve file from. So that's why I was able to actually change the files, and it would still serve the files with the changes. That's because it's actually reading from my local file system and not from the actual container. Other useful flags that you can use, we can use -d. So in this case, I ran my container in detached mode or in the background. You can use --rm. So when you start using containers, you will see that it takes up a lot of disk space. So you have to be careful about that. You have to remove your various containers once you're done, just to clean up the disk space. So using --rm as part of the command line makes it a lot easier. --name if you want to give it a name, especially if you start automating some of your containers, you'll want to give them a name so that you can refer back to them later on. So to start a container, this is the command that I've used, docker run, -d to run it in detached mode, --rm to clean up afterwards, --name to give it a name so I can actually stop it and access it easier afterwards, -v to mount a volume, -p to map some ports, and finally the name of the image that I wanted to run. And that's it. I was able to run this application, and it was, well, you know, you have to memorize all of those commands, but it's really quick, it's really fast. You saw how fast it was to actually start that server. So you can also run different things. So I've used Apache in this case, but you don't need to use containers for servers. You can also just use it for executables. It just spins up an environment that has that executable pre-configured and ready to use for you. I've used PHP a lot in the past. It's a language that is relatively easy, and I actually find it easier to use PHP or JavaScript to do some scripting even on my local file system than using Bash. Bash is cool, Bash is nice, it's a great tool to be able to master, but I'm much more comfortable in JavaScript or PHP. But I don't necessarily want to install PHP, but I can kind of create a small script that I could run. So you could do a small script and you just use PHP 7.1 in this case, which is just a container that has PHP pre-configured, only the executable, not the actual server in this case. And then you can pass it a command to be executed once that container is started. So in this case, I'm telling our container, once you're started, run PHP and execute this file, this PHP script. You can also specify a working directory, so you can mount a volume into /app, for example, and tell your container to use /app as your working directory, and then you can just run PHP and the name of the file that you want to execute. So I actually have this scripted already, so script /php cli.sh, and you can see that I ran docker run and this big command here. And what this cli.php PHP script does is that it just counts the number of files in a folder and outputs the number of files. So this is what happened. So it actually ran that PHP script here, and I got the result. So I still don't have PHP installed, but I'm able to run PHP scripts on my machine. If you want to run a Node.js server, very similar, specify the version of Node that you want to use. Once again, I'm using an outdated version. Why? So you should probably use Node 14 by now, but in this case, I'm using Node 10. You can see that I'm mapping port 8080 to the port 3000. So my Express server is running on port 3000, but I'll run it from port 8080 on my local machine. And once the image is started, run node/app, which is where my Express server is located. So I can actually run a Express server now. So I also have this scripted. So in scripts, node server.sh. So this is the docker command that I've just run. So docker run, I've actually mapped port 3000 to port 3000 in this case, just so that it doesn't conflict with the other one that I have running. I give it a name, my node, and I map some files, and I use the image node 12, I think, in this case. So now it's actually running. I can do curl localhost 3000, and we have our hello world file, so it's actually working. We've got an Express server up and running. Good, I'll just stop this container from running. So docker stop my node. We don't need this anymore. And it's gone. So no more works on my machine. We finally solved this problem. So now you actually ship your whole environment. So there's no more issues with somebody potentially running a conflicting version or any of those problems. So I was very happy that I was able to run this application, but I was still getting an error, something about a file not found. So I asked my friend, you know, hey, I don't know, I'm getting this error. And he said, oh, well, do you have the file c/temp/log? I was like, oh, really? Hard-coded path? Who does that anymore? Oh, man. And I mean, I don't even have a C drive. I have a Linux machine. So how can I access those files? And this is where environment variables will come into play. This is where you'll start using environment variables and they're very, very useful when you're dealing with containers. Now, containers is great because you're actually shipping the whole environment, but sometimes there are little things that will be different from one environment to another. If you're relying on the local volume, in the case of this example I've just told you, well, the name of that log file will be different from one machine to the other. So you can store variables that will be specific to your environment. Another example could be the port on which your server is running. There's a good chance that you'll run your application on port 80 on your production server, but you'll probably run it on port 3000 as you're developing your application. So you might want to store that as part of an environment variable. So file names, ports, base URL, the URL that you're using to access your API. So you probably have a testing API that you can poke. You probably don't want to poke around with your production API as you're developing your front end. So you could use your base URL as an environment variable. To pass an environment variable to Docker, use the -e flag, give it the name equal value. It's as simple as that. And then when you're using a PHP application, you can use $_env to access your environment variables. And in Node.js, you can use process.env, the name of your variable. So why don't we take a look at a Node.js example. So scripts with an S, node.env. Oops, what is it? Oh, / scripts / node.env.sh. And there it is. Good, so the first command that we ran was docker run. We specified name equals Joel. Notice also how I've used node 12 in this case to run this specific command. So the output was hello Joel, which is what we expect with this environment variable. And I've also used process.version to output the version of Node that this is currently running on. The second command was docker run. I've used the environment variable name equals world in this case. And I've used node 8 for that second command to run. So hello world in this case instead of hello Joel. And I'm now running node version 8.17. So you see how it's easy to ship your whole environment so that you can actually test out your code. If you had to migrate from 8 to 12 in this example, well, you can see that it's easy to run the exact same code with a different version of Node, and then you can see what are the errors that you're getting and how you can fix them. So it makes it very easy to still have working version, but work on it as you see fit. You can also use environment variables to initialize your containers. So in the case of something like MySQL, for example, the database, you'll probably want to specify a bunch of different things. You'll want to tell your container, well, this is the root password that you'll be using, or create this user, and that's the user that I will use to access my information. So you can specify those as environment variables. Now, each image is very different, so you'll have to actually read the documentation. Sorry, but hub.docker.com is usually very good with that. They provide you with all the information that you need. So if you have some sort of a setting that you think you might be able to tweak, it's probably in there, and you'll probably be able to change that. Speaking of MySQL, I'm going to show you an example. I'm going to start a MySQL server, but there's an interesting thing about some images. Not all of them, but some images provide you with an entry point. So you can actually mount a volume into that entry point, and any file that will be stored inside that folder will be automatically executed as the server starts. So in the case of MySQL, it will actually look for .sh files, so any shell files, and it will, or shell scripts, and it will execute them. But it will also look for SQL files that are there. So you can easily initialize a database with some sort of initial data set, all of your create tables and all that stuff you can store into an initial data set. So every time that container will start, it will have, or it will come with that initial data set that people can use. So that's great for testing. It will automatically pre-configure and configure all of your database. It's great if you have open source projects and you want to provide your potential contributors with some sort of sample data. So that can be very, very useful as well. So why don't I go ahead and start a MySQL server. MySQL.sh, I think is the name. So there it is. So I now have a MySQL server. Let's go into here and let's see if I can actually take a few seconds to log inside that container and see what is inside that database. So I'll do a docker ps again just to see what's there. So I've got my MySQL. So let's do a docker exec. -it, and I'll come back to that in a few seconds. And I'll run /bin/bash. So now I'm logged inside my MySQL server. I can actually run MySQL -u, I believe it's user -p password. Actually, it's probably root /p root, because yeah, why not? There you go. Never use root as your password. Not a good idea, but hey, makes it easier for demos. And from here I can see list databases, I think is the, no, show databases. There it goes. I can see what I have in here, so I have all the regular stuff. Good. So I was able to start a MySQL server without actually installing it on my machine. Once again, that's very important. So, and it was already pre-configured for me. So that was nice, but let's go ahead and we'll stop this MySQL. And what I want to do is to actually show you something else here. Let's use that entry point. So I'll have a script that actually uses my entry point. Script /MySQL init. So Docker run, and you can see here that I have my volume mounted. So I'm mounting init.sql. And MySQL, once it starts, will automatically run this SQL script for me. So that's good. And why don't I run scripts /myadmin.sh. And watch out, this will blow your mind. Let me just open up a window in my other screen here. What port is it on? Oops. There it is. Ha! Look at this. phpMyAdmin. So already I have an Apache server running PHP that automatically links to my MySQL server that I've just started inside a container. And in here I have presentations. So this is a table of conferences and various conferences at which I've given this event. How cool is that? You can see that automatically with two containers I was able to start all of my SQL, spin up my phpMyAdmin, all of that stuff so easily with just a few simple tools, just a few commands that I've used. And I've never had to install any of that. I don't know if you've ever tried to install phpMyAdmin, but it's a lot of work if you just want to manage your MySQL database. All right, but there's more than a CLI. So there's a lot of commands that you need to remember. There's a cheat sheet that I will share at the end with you that you can use for very specific examples like those that I've shared so far. But we'll also talk about the Docker file. The Docker file is a tool that can help you. It provides you with the same options as a command line. It has a standardized set of commands, but it lets you build your own images for sharing. So that's the very cool part about it. It builds stacks that can then be shared through a registry. So a Docker file for a PHP project, basically you start from an image. You always start from a base image. So from PHP 7.1 Apache, you will expose different ports, and that's not even needed because it's already part of that base image. And then you just copy your files over, and you've just created your own container that has not only PHP, Apache, all that stuff, but it also has all of your source code. So you can then take that image, ship that over to your production server, and just let it run. If you want to run or create a container or a Docker file for a Node.js project, very similar. Start from Node 10 in this case. Expose your ports. In this case, it's very important because Node does not expose any ports by default. Copy all of your source code, change your working directory, run npm install, and run npm start. That's it. Your image is now ready to go. And all of that npm install is already done. So when you actually start that container, it will just run that npm start. So that's why the cmd at the end. And it immediately starts your server. It's up and running, pre-configured. It works everywhere. So that you can just build those images. All right, so to compile your own images, Docker build and the path to your Docker file. So technically, most of the time you would just use Docker build dot because you're in that working directory. You also want to give it a name, so you'll have to provide it with a tag, so -t for a tag. All right, warning, your containers might be running as root, so something that you might want to keep in mind. I will provide you with a link at the end that kind of explains what are the problems with that. You can take a look later on. Docker build, so it creates a full custom image for you to share. Images can be shared on registries, and the image is ready to share with your team or to deploy directly to your server. In order to share those images, you can use public or private registries. Docker Hub is the one that I've mentioned a lot already. It has a lot of official images there, but you can also use it for your own images. You can use public images, or you actually have access to free public images, but you can also pay for private images if you'd like. If you want to have your own registry, your own internal registry, you can use Quay, which is an open source project by Red Hat. It is exactly what it is. It's a private registry that you can use and deploy into your own infrastructure so that you don't have to rely on an external third party. Also, Google, Azure, IBM, all the major players, they all have their own registry. If your application is being deployed on Amazon, for example, well, you'll probably want to use their registry just because it'll be faster. Everything is in the same infrastructure. So to publish to a registry, Docker push, and you give it the name of your image, but you'll need to specify the name of the registry, followed by your username, followed by the name of that container. So in my case, I can do Docker push, docker.io, which is a registry where I want to push that image, /Joel Lord, which is my username, better than the 2 underscores there. And then you specify the name of the image that you want to push there. You will have to be logged into that registry before, so you can use Docker login beforehand to log in. Once somebody has pushed an image, you can then pull that image by using Docker pull, and then just provide the name of the image that you want to download. All right, so I've talked about a lot of commands. Here's a few other commands that you can use. Docker ps, you saw me use that just to list all the running containers. Docker ps-a will list all the containers, even those that are currently stopped. Docker stop and the name of an image to stop a running container. Docker rm will remove a container just to clean it up. Docker tab is very useful to rename your containers as well. So debugging, Docker logs to view logs, Docker exec to run commands or login, Docker cp to copy files to and from. So that can be useful if you need to check on the configuration file for your server or things like that. Running multiple containers. If you have multiple containers, and I don't want to go into too much detail of Docker Compose, but if you have things like PHP and MySQL running, you'll want to run those two as two separate containers. But you'll probably want to have a way to make it easier to get all of them up and running at the same time with one single command. So Docker Compose can be very useful. It uses YAML files to describe all the containers and all the structure that you have. So in this case, I have two services. I have a database and my web service. And I can, using something like the Docker Compose up, I can start both of those services and make sure that it runs easily and in the same way in all environments. So, should you use containers? Well, hopefully I've convinced you by now that for your day-to-day development, you should definitely use them. It will definitely make your life easier as a software developer. You don't have to worry about having all of your runtimes, having all of your system updated. You don't have to worry about any of that. You can just package up all that you need to run your application. It does make it a lot easier for a day-to-day development job. For testing, it's great. It makes it easy. You can put in as much garbage inside that database and just destroy it once you're done. It also fixes the works on my machine issue that you had with your manual testing team. So it really fixes a lot of issues. So very, very useful for testing. And for open source projects, it is so much easier for potential contributors to be able to help you with your project. If you have something like Docker Compose already set up, they can just do Docker Compose up. Everything comes in, everything is configured, you have an initial data set, it makes it so much easier for them. As a matter of fact, I love open source so much that if you have an open source project and you need help to containerize that project, I would be more than happy to give you a hand to build those Docker Compose, Docker files, and so on, just to make it easier for your potential contributors. So just let me know. You can reach me on Twitter, Joel with 2 underscores Lord. So right there, on the other side, all the information is there. There's one link that has a lot of information. There's the actual container that you can download to run those slides because those are not available as a PDF, but they are available as a container. You'll also find a few good links that I really enjoyed. There's a link by Gary Garfield on how containers actually work. There's a link on why you shouldn't run containers as root, and so on. So go ahead, take a look, easy URL to/containers. And if you have any questions, any comments, any feedback, feel free to reach out on Twitter, Joel__Lord. That's me. Thank you.